Can you see the screen? Is the screen visible?
Yes, sir.
Okay, fine. So let's, yeah, not visible?
Sir, it is visible.
Visible, sir.
Okay, fine. Okay. Okay, fine. So let us continue the discussion on natural language processing and text mining, which we are having in the last class. So as we had said that for any natural language, there are the following are the main building blocks. The first is the vocabulary or the set of words or the set of valid words in the language. Second is the grammar, like which basically is it like basically specifies how a sentence can be correctly constructed. That is like every like vocabulary consists of the words, so along each word is associated with a part of speech, like right, say noun, verb, etc. So the second part is grammar, that basically specifies what like what sequences of parts of speeches are valid as a sentence. Like for example, as we are saying that a sequence like verb, adjective, verb, right? Or maybe noun, adjective, adverb. These kind of things are probably not acceptable sequences, right? So like the grammar basically specifies what sequences of parts of speeches are acceptable and which are not. And the third building block are the semantics. The semantics are related to the meanings of the different words. So, so regarding the semantics, which deals with the meanings of the different words, we considered an important resource, which is the WordNet. Now, what is WordNet? As we saw yes in the previous class, WordNet is basically it's an online resource where like different words, like basically all words in the English language are present. They are stored uh, along with the following informations. One is their part of speech or POS. Secondly, their meanings. So each word can have multiple meanings. We all know that. So for every word, its meaning is explained in using one sentence and an example, and its part of speech is also specified. Additionally, along with WordNet, we have a graph which is like the WordNet graph. So it's like such a graph whose different vertices are the different words in the English language, and then or in fact that's not true. Basically the WordNet basically consists of synsets. What is synset? Synset is like a set of words which are synonymous, set of synonymous words. So in the WordNet graph, these W1, the vertices W1, W2, W3, W4, etc. These are actually nothing but synsets. These are not necessarily individual words. They are synsets. That is to say, they can be like several synonymous words also. And then there can be different kinds of edges between every pair of words, depending on the relationship between those two words. Say for example, like if one is like there can be antonym edges, like say for example, if W3 and W4 are opposite meaning, then they can have one kind of edge. So let us denote maybe this kind of this is one kind of edge. Then maybe like is an then we have to consider talked about hypernyms and hyponyms relations. So if W3 is a specific case of is a specific example of W1, that is W1 is general and W3 is specific, so we can say that one is a hypernym and the other is a hyponym. So like we can have directed edges like this, that is from the specific to the general we can have an arrows, right? And other kinds of relationships between different words or different scene sets are also included in the WordNet. Okay, so this WordNet is an extremely important resource when we are trying to do natural language processing. Now, like now the kind of tasks which there are many tasks which people solve using natural language processing. The particular task which we are interested in, remember, is sentiment analysis. So like we have, like when Professor Siddhartha Chattopadhyay gave his talk, like one thing which he highlighted several times is the importance of sentiment analysis. That is to say, like for example, we are trying to understand different news articles. From news articles, we are trying to understand what is the situation in the world, how is it going to affect my company, and so on. And so for that, so the inputs to my whatever is my algorithm, the input to that will have to be the different news articles from which my from my algorithm will have to understand or predict whether how the situation is going to be for my company and so on. So for that purpose, uh, we will focus like in these lectures we will focus on those tasks of NLP which are related to this sentiment analysis. So the first thing that is to say, before we can do sentiment analysis, what are the different pre-processings that need to be done on the news documents which we are getting or which we are receiving as an input. If we consider one more example or one more economic application of sentiment analysis, say for example, we have customer reviews, and for that is to say customer reviews about certain products, and we want to understand that like which aspects of the product people are happy about and which aspects of the product people are unhappy about, right? So like the customer review is of course some kind of a free text. For example, like this, I bought a camera, its the quality of pictures taken by it are quite are quite great, however the battery life is not that good. So suppose this is a thing. So in this case, the important concepts that are being talked about or the important aspects that are being talked about are, first of all, picture quality, and the second is battery life. Okay, so about picture quality, we are saying it's great, and about battery life, it is saying what is being said is not so good. So one is a very positive sentiment, the other is a slightly negative sentiment. So this is what we really are trying to find out. That is, for our first task will have to be to understand that what are the aspects of the product which people are talking about. And the second thing that is our first aim. The second aim is to understand what are the sentiments associated with it, right? So for that purpose, the first thing that is needed is to identify these aspects. I mean, of course, we know that for a particular product, what are the normal aspects to look for, that we already know. So one thing to do is, like, we can that is to say, once we have got a customer review, one thing that we can do is we can simply search for the particular aspects that we are looking for. Okay. Now, it may happen that a customer has written, instead of writing, say, picture quality, suppose someone has written, say, a photograph resolution, resolution of photographs, which basically means the same thing. Or instead of writing battery life, suppose someone has written some other the same thing someone has written in a different way, right? So that is, we know that people can write same things in different ways. Now so for that purpose, just searching by fixed keywords like picture quality or battery life may not be may not always be a good idea, because I may have, that is one, any customer may have written the same things but in a different way. So for to understand what the customer has said, that is when your algorithm is basically going word by word of the customer review, you have to, it is necessary for our algorithms to understand that which words are related to which of these aspects of the product which we are interested in. So for that purpose, what is the task that is needed here is word sense disambiguation. So what is this word sense disambiguation? The thing is that that is the same word, as we have as we can understand, the same word can have different meanings. Now in which sense is that particular word being used in that context? This is a this is a the problem of finding this out is known as word sense disambiguation. Now, of course, this word sense disambiguation is a big problem in natural language processing. It's not restricted to this problem of sentiment analysis. Irrespective of sentiment analysis, also word sense disambiguation is an important problem. So let us briefly talk about some approaches in which we can do word sense disambiguation. Okay, so let us look at this example first of all. So, this is just an example of why word sense disambiguation is important. Say, for example, consider the word serve. So here we can see that the word serve can mean two different things. In one case, we are talking about Eagle Airways, which has applied to serve New York. Means that that is a particular airline has a service to a particular city. So service in that sense. So the word serve is being used in that sense. That is, it is providing some kind of a service. On the other hand, here another example is like here it is something related to say food. So when we are talking about serving food, that means a different kind of thing. It basically means that is like offering a food in a like when we go to restaurants, the waiters often offer to serve the food. What does that mean? So that means like distributing the food or on our plates or something like that. So serve can mean two things now, which may not be completely different senses, but they are in like but somewhat different senses. Yeah, again, if you consider this word dish, so dish can mean say plates. Dish can also mean some food items, right? And now it can also happen that different senses of the same word may belong to parts of speech. Right, to different parts of speech. It may happen that the same word is sometimes a noun or sometimes an adjective, sometimes a noun or sometimes a verb, and so on. So so the task of word sense disambiguation is basically to like given a particular sentence which and a sentence, as we discussed on Monday's class, is a sequence of word tokens. So like what all these things that are written here, each of these is not really a word but a word token. The word are the like the you can say the unique words or the elements of the vocabulary, and what you see in a sentence is basically realizations of a word, which is called a word token. Okay, so now it may happen that a particular word may have different meanings. Say, as we saw, the word serve, it can have multiple meanings. See, the word dish can also have multiple meanings. But when a word token is present in a sentence, that word token has only one of those meanings. It cannot happen that the word token present in a single sentence is having different meanings. So that is not possible. Whenever I am using a word token in a sentence, like it will choose one of the different possible meanings of the corresponding word, which is a vocabulary entry, right? So like again, if you consider this word book, we know that book can be either a noun or a verb. Book as in the book that we read, and book as in like when we are booking a ticket, that kind of thing, right? So here when we are talking about a sentence like this, Now this book, this is a word token, and so either it belongs to the first sense, that is which is a noun, or it belongs to a second sense, which is a verb. Now which sense it belongs to, the understanding which sense this particular word token belongs to, that is called the task of word sense disambiguation. Now in some situations this might be an easy problem. It is an easy problem, especially if like it has only one meaning. Okay, so those words which have single one, these can be easy if each for those words which have single meanings or single sense words. It can also be that like if each sense is associated with a different part of speech, then also it's fine. Each sense has a different POS. So for example, so like in case of book, as we understand, the two senses are, one is a noun, the other is a verb. Now in this case, like if we suppose we have this sentence, then there is this technique of part of speech tagging, right? POS tagging, which we briefly mentioned on Monday. So that will tell you which word token is a noun, which is a verb, which is a pronoun, etc., etc. So that way you will understand that in this case, I mean this particular word token is a noun. Okay, and we know that the word book has two senses, one is a noun and the other is a verb. So since we know that this particular token is a noun, then we immediately understand that it is the first sense which is being used. So if each sense has a different POS, then also the problem is easy. But if if neither of these is true, that is to say, if there is a word which has multiple senses, and then within the same POS also there are multiple senses, then the task becomes non-trivial. That is, it's not necessarily difficult, but it's not so easy. That is, we need more algorithms for that. Okay, so for so one simple way to, that is a really naive way to solve this problem in that case, is simply you just use the most frequent meaning of the most frequent sense of the word. That is that is with the help of resources like WordNet, it is actually possible to calculate the statistics, that is which sense is used how many times. Like if you take a really large corpus and do a and manually do the word sense annotation, then you will that is which is which has actually been done by various researchers. It turns out that some versions of WordNet actually contains that resource, that is says like it contains an information like this. That is there is a word like this, let us call that as say W1. It has three senses, let's say. One is S1, the other is S2, and the third is S3. It will also contain the information that this is a noun, this is also a noun, and this is an adjective. Along with it, it contains the information like that is in a very large corpus. Whenever this word W1 is used as a word token, 73% of the time it is used in sense 1. In only 12% of the time it is used in sense 2, and in the remaining 15% of the time it is used in sense 3. So if this kind of information you have, then you have a rather naive approach to word sense disambiguation. So whenever you come across any word token, you simply assume that its most frequent sense is being used in that particular situation. Okay, in that particular word token, which is of course a rather naive way, because we know that in this particular sentence there is no reason to think that the most frequent sense is being used. So since this is a naive approach, so then we have to think of something more sophisticated. So for that purpose, what is important is to look into the context of the word. So here this concept becomes very important, and this concept of context, this is something which starts from word sense disambiguation, but it pretty much continues throughout the throughout natural language processing. So whenever we have a sentence, okay, so as I have said several times, a sentence is a sequence of word tokens. So suppose you have the word token whose meaning you are trying to understand. So that let's say that the sentence is something like this. Just assume W1, W3, W12, W4, W27, W86. Let us say that this is a sentence. Okay. And so it's as I said, it's a sequence of word tokens, and each word token maps to a particular word in the vocabulary. Now suppose that this word W4, this is my target. I am trying to understand the meaning of this word, or which sense this word is being used in this particular case. So what if we go to the WordNet entry of W4, let's say we find that there are three senses. Again, let me write it S41, S42, and S43. Okay, and I also have the part of speech of them. This is noun, this is also noun, and this is an adjective. Okay. Now what I do is I do a post tagging of this sentence. So what is there are standard algorithms for post tagger. So let us say that the post tagger tells me that this is an article, something like this is a noun, this is a verb, this is a noun, this is this is a preposition, and this is another noun. Okay, something like that. So like this W4, which is what we are focusing on. So this is a noun. So this third sense I can rule out right away. So this is an adjective, but this is a noun, so we are dropping it. So it has to be either S41 or S42. So the question is now whether this particular usage is S41 or S42. So for that purpose, what we need to do now is, as I said, one possibility was of course to see which is more frequently used. Either maybe this is, as I said, this may be used has been used 70% of the times, this has been used 12% of the time. So I just assume that S41, this sense is being used, which is not a great idea. So a better idea might be to look around in the vicinity, look at the other words. Which are the words in the same sentence surrounding that word W4? So these are the words which basically form the context of the target word. So what is context? Context is basically the surrounding or neighboring words in the same sentence. So it often happens that it's the neighboring words which contain the cue that which sense is being used, right? So so based on this concept, there is an algorithm. There is an algorithm called the LESK algorithm, which is I mean straightforward but quite powerful. So let us look at what this LESK algorithm has to say. What the LESK algorithm, it's basically it's the idea of it as follows. The sense SI of the ambiguous word W is likely to be the intended sense if many words used in the dictionary definition of SI are also used in the definitions of the words in the context window, right? So okay, so let us first come to an example that will help. Let's look at this example. Okay, the keyboard of the terminal was. Now I am trying to understand the sense of this word terminal. Now if I go to WordNet is giving me that this word terminal has three senses. One is this one is related to like electrical devices. The second is related to transportation, say rail terminus or bus terminus, something like that. And the third is related to computer terminals. Okay. So there are these three possibilities are there. The question is, in this particular case, which sense is being used? So as a human being, if we are given this sentence, we will immediately say that the third one is being used. Why? The reason is that the presence of the word keyboard in the surrounding, right? We see that the content. So this is the target word, so, and we are talking about context. So what is context? Context is the surrounding words. So now, of course, the context in this case mostly contains the, of, the, was, which are effectively something like stop words. It's so they do not really contain much information. But this word keyboard is also there. Now this keyboard, as we know, is associated with a computer. So and this third, and we see that the sense 3 of the word terminal is also contains computer, right? So what we are effectively doing here is that so basically what we are doing is that we are trying to find the wordnet distance between every context word and the target word. So we had we have already talked about the wordnet as a graph, and when there is a graph, like two words will also contain a distance. In fact, we talked about that also in Monday's class. So so what we are that is what considering the wordnet definition of keyboard, and we are also considering the wordnet definition of terminal, and then we are seeing which sense of terminal, the target word, has an overlap or intersection with which other sense of the word keyboard, or the definition of keyboard, right? So as you can see, if you when we are talking about keyboard can have at least three different meanings. I mean, here they have written it twice, well, two, but like we know that so one meaning of a keyboard is keyboard of a computer. The second is meaning is the keyboard as a musical instrument. The third one can be like a board from which keys are hung. Okay, so these we can say that this has three senses, and that is the target word terminal. This has three senses. The context word keyboard, this has two or three senses. So what we are now going to do is we will take every sense of the context of the target word and see which of the whether it has any intersection with the any sense of the context word or not. So here we see that this, if you consider this one, this definition, and you consider the first definition of keyboard, you will probably find no intersection except for these stop words like the, at, etc, etc. Those we are not interested in. So basically there is no intersection between this and the first one and the second one. Similar now, like if you consider this sense, that is the first sense of the target word with the second sense of the context word, here also I do not see any overlap. Okay, so then I think that okay, probably this is not what I am looking for. I mean, this sense, the first sense of the target word, is probably not what we are looking for in this case. The next I come to the second word. Again, I take its intersection with both meanings of the context word, both senses of the context word, and in this case also I do not find any overlap. Like neither of these are related to transportation, vehicle, passenger, nothing is there. So this is also probably not useful. Now we take the third one, so and we take its intersection with the first one. Now here of course we find an overlap, computer. So uh, uh, so we now understand that okay, there like if you consider computer as an overlap, then that is there is a, I do find an overlap of the senses of that is of sense 3 of terminal with the context word keyboard. Okay, so that is how I choose that. So the first two senses of the target word I discarded because I could not find any relation or any overlap with any meaning of the context word keyboard. But when I took the third sense, then I could find that at least some overlap I could find. So I decided to choose the third sense. So this is what the LESC algorithm is all about. So what basically what's the LESC algorithm? What the LESC algorithm does is so consider. So suppose you have a target word. Input is a target word and context words. So target word, let me call as T, and context words. So in that example, there was only one context word, but let me call in general there can be more than one. So let's say that C1, C2, etc. up to CS or whatever C end. These few are the context words. Now what happens in LESC algorithm? You consider like let us say that the target word T, it has k senses S1, S2 up to Sk according to WordNet. Meanwhile, that is if some that is all these senses of course are related, like they are associated with the part of speech also. And what you can do is you can actually do the part of speech tagging of the word. So that is, you already know what's the post tag of the target word T. So you can focus on only those possible senses which have the same part of speech tag. The other ones you can ignore. Okay, now what you do, that is for this sense, you have a sentence in WordNet. Let's say by S of S1, what I mean is WordNet definition or the WordNet definition sentence. Now what do? You take this sentence and you take the intersection with the WordNet definitions of every that is all C1 of all the context words one after another. Okay, you calculate this thing, this intersection, and so let us say that in this case whatever value of the intersection you get, let us denote it as I1. Then you take the sense of sorry I11, okay, the first sense with the first context. Then you take the second context word. Again you take the intersection I12, and similarly you do this process for all the context words Cn. This way what you get is I1 end. Now you can that is, now you based on this you can actually calculate what's the intersection with the entire context. So that you can you can calculate it as the sum of these things, I11, I12 up to I1 end. So it's like saying that for the first sense, that is it has this much of overlap with the different context words. Then you take the second sense. So this I let me call this as say what to say, let's call it as O for overlap, O1. Then similarly I also calculate for the second sense, I calculate these I do this, I repeat the same process in this way. So this is the WordNet definition of the second sense. I take its intersection again with S of C1, and this I call it as I21. Similarly, I can get I22, etc. So and after I will add all of them up and I will get O2. So so just repeating this process for S1, sense S1 I will get O1, for sense S2 I will get O2, and so on. For all the senses I will get O1, O2. Okay, so these O's basically stands for overlap of sense with context. And then the sense which I will choose is that whichever sense has the highest overlap. So that is to say arg max of O1, O2 up to OK. So if if for S3, if the the overlap O3, if this is the largest, then I will be choosing the sense S3 for the target word. Okay, so this is what LESC algorithm is all about. Now there are so apart from the LESC algorithm, there are some other things also. You can some other approaches to word sense disambiguation also, which you can do. So one example which I will quickly give is the statistical WSD. So if you remember in Monday's class, we had briefly told how to do the document classification. So that is to say, we are saying that there are like documents like this, or and each document is associated with a label. And what we had to do is we have to given a document D, we had to predict its label, something like this, right? Given D1. Now what is D1? D1 is nothing but a sequence of word tokens. Right, so that is, a document is a sequence of sentences and a sentence is a sequence of word tokens. So a document is a sequence of word tokens. So then what did we do? So we wrote it in this way. So that is, we use the Bayes theorem to write this P of, that is, probability of label given the document is directly proportional to probability of the document given the label times probability of the label itself. Now how do I get the probability of the label? This is from the statistics in the corpus. So it depends on like for this purpose we need a labeled corpus, that is, we already need lots of documents along with their associated labels. So if these labels are say as we are saying in the previous class, say sports, finance, science, etc., then we will see that how that is, given any random document in the corpus, how likely is it to belong to the class or the science, or how likely is it to belong to the class of sports. So that kind of information is like you can get from the corpus statistics. Now coming to this part, what this D is the basically the document which is nothing but the sequence of the word tokens. So this I can write as follows: I equal to 1 through n P of Wi given yi. That means what? So what is this Wi? These are the word tokens in the document. That is to say, we just assume that all the word tokens are independent of each other given the label, and we are actually just calculating these these probabilities and just multiplying them. So what is this basically saying? This is saying how likely this particular word token is to there is this particular word token Wi, how likely it is to appear in the word in a document whose label is y1. Say for example, if I am considering a word like if this word is atom, okay, and this y1 is this label which we are considering, suppose this is sports. So how likely is the word atom to appear in a document which is about sports? So very unlikely. So this will have a low value. On the other hand, if we if this y1 is science, and in that case that is in that case, if we are considering this probability, P of atom given signs. So that is basically saying that how likely is the word atom to appear in a document which is on signs. So you can say that it is reasonably likely. So you can say some 0.25 or something like that. So this, which is a like maybe it's a high value. So this way like that is we will write this as a like as a product of many terms, some of which will be high, some of which will be low. So that way we will repeat this for all possible values of y and then see for which value this probability is the highest, and accordingly I will assign the label. Okay. So it's like saying that given the document, given all the words in the document, what is the probability that the level of the document is science, or given all the words in the document, what is the probability that it is of sports. Okay, so you will have to calculate all these probabilities, and for whichever class or whichever level this probability is the largest, we will predict that class. Now this same idea I am going to use here for word sense disambiguation. So once again you consider the particular that is like let's consider a sentence with the target word which we call as W, and let us consider some of its surrounding words C1, C2, C3, C4 and C5. So these are the context words. Okay. Now how many words you will consider as context, that is entirely up to you. You can consider a small context, you can consider a big context, you can consider only the previous and the next words, or you can consider the entire sentence, or you can consider 10 words on both sides of the word of the target token and so on. That's entirely up to you. So in this case I have taken a that is one standard thing to do is consider the rest of the words in the sentence as a context. Okay, so that's you can assume that that's what I have done here, since the number of words on the two sides, right and left sides, are different. That suggests that what I have done here is like this is this target word, it's like the middle word of a sentence, and the rest of the words in the sentence I have just taken as my context. Okay, so this is context. So now what I am going to I am not, so like I know from word sense that this target word W, like it has k senses, S1, S2 up to Sk. Now again, of course, my the task here is to identify which of these k senses is being used here. So I am going to form it as a classification problem. So I am going to write probability of S1 given the context. So what is the context? By context I mean the context C. I mean this set of words C1, C2, C3, C4, C5. Okay. So this probability I will try to calculate. Similarly, I will calculate this probability. What is the probability of sense 2 given the context? Similarly, what is the probability of sense k given the context, etc. Okay. So how do I do that? In basically the same way, using Bayes theorem. So here what is Bayes theorem saying? Bayes theorem saying is that this thing is proportional to C given S1 times P probability of S1. This one is probability C given S2, probability of S2, and so on. Now if you consider the last terms, P of S1, P of S2, P of Sk, etc. So how to evaluate these terms? Now I had already told you that WordNet can provide us the statistics of the different senses. That is, whenever this word is being used in a large corpus, that is like WordNet has access to like a very large corpus where the different which has been manually tagged, and every word token has like its proper sense has already been identified by a human and marked also. So on the basis of that, like we can calculate these P of S1, P of S2, etc. It's like basically saying that whenever this word W is used, 70% or maybe 30% of the times it is this one is used. It is used in the sense S1. So I will write this probability as 0.3. And say 48% of the time it is used in the sense S2. So this probability I'll write as 0.48. Okay. So this way, these things I can evaluate. The question is, what about these things, right? How to calculate these? So here, what we are saying is that what is this C? C, as I have already said, is the context, which is the collection of of all the context words. So just like I had assumed, I had made this kind of assumption that given the label, all the words, or I mean all the word tokens in the document are independent of each other. So because of which I could write it in this way. So here again, P of C given S1, this I can, like I assume that I can write it as P of C1 given S1 times P of C2 given S1 times etc. all the way up to P of C5 or Cn, if you want to say, given S1, where N, what is N? N is context size. This is the context, the size of the context is N. Okay. So now what is this? This is saying that whenever the word W is used in the sense S1, what is the probability of finding this word C1 in the surroundings? Okay. It's that is so say if the word W that we are talking about, if this W is cricket, we know that it has two senses. Sense one is the sport, that is cricket, and sense S2 is the insect, that is cricket. Okay. Now the different, so now I am trying to understand which sense is being used. So let us talk about this first context word C1. Let us say that this is bat. Okay. So now here the question that, like what we are saying is, what is the probability that the word bat is found in the context of S1, that is sport. That is, whenever the word cricket is used as in the sense of sport, what is the probability of finding a bat around it? So we understand that whenever one is talking about cricket, they may talk about a bat. So this probability can be reasonably high, say 0.18. Okay. But what about the probability of bat when insect is being used? Now, as we know that bat is also an insect. I mean not an insect. Sorry, it's an animal. And cricket and bat. When we are talking about cricket and bat, we need not be talking about a sport, but we may also be talking about insects and nocturnal animals. Right? So there is a possibility that when we are mentioning insect, the animal can we may also be talking about the animal called bat in the neighborhood, I mean in the context. So this probability is also not too low. So we have to maybe 0.8. Okay. Then we have to look at that is just based on C1, we could not really make a decisive difference about whether that is sports is being considered or insect is being considered. Okay. And now so that is why it is usually not enough to look at one context word. We have to look at more context words. Say let us look at C2. So let us look at C5. Okay. So C5, let's say that this is a stroke. Okay. So and in this so that is so in this case we are being asked, that is, how likely is the word stroke in the presence as a context of the sense that is whenever the word cricket is used in as a sport, what is the probability of finding a word stroke in its context? Like it may be reasonably high. But when we are talking about cricket as an insect, what is the probability of finding stroke in its context? Probably much lower. So some of these terms are going to be high, some of these terms are accordingly going to be low, and we will calculate this both for S1 as well as for S2, and then decide, that is when we are see like is calculating these probabilities, which we call as the posterior probabilities. We will see for which sense, that is given the context, which sense is most likely. So this is basically saying that given the context, which sense is most likely, or what is the probability of this sense. And here we are saying, as we are calculating the opposite thing. It's like saying that given that this is the sense, how likely is the context words? And this is like simply saying how likely is this sense, irrespective of the context. Okay. So this way, so what we are looking at here is, given the context, we are trying to calculate the probabilities of the different senses. And we are able to calculate these probabilities with the help of a large annotated corpus, where the different senses, different occurrences of this word is tagged with the sense, so that we can understand which sense is how likely. And additionally, the contexts are also present. So the contexts have also been annotated, so we can just simply calculate these kinds of probabilities. That is, given a particular sense of this word, how likely is each of the context word to appear in its surroundings. Okay, so armed with such a massive resource, we are able to carry out this kind of statistical word sense disambiguation. Okay, so now, having done the word sense disambiguation, let us now try to come to our main task, which is sentiment analysis. So if you remember the use case which we are talking, so we have a sentence. Let us say we are talking about the customer reviews. So in a customer review document, what happens? The user will mention different aspects of the product, and along with and it will express some kind of sentiment, either a positive sentiment or a negative sentiment, something about that particular aspect or aspect of the product. So whatever we are talking about earlier, let us come back to it. Picture quality is great, but battery life is not so good. Okay, so now with the help of techniques such as word sense disambiguation, I have identified that these things, this picture quality, battery life, these are related to the aspects of the product which I am interested in. So that is, I already have a list of aspects of the product, say A1, A2 up to AM. Now, in each sentence, I have to understand which aspect is being talked about. I understand that this is one of the aspects. Let's say maybe A3, and this is another aspect, maybe A7. So that mapping I am able to do with the help of word sense disambiguation. Now the question is, what sentiment is being expressed about A3? What sentiment is being used about A7? Okay, so for that I once again need to consider the context. Okay, so what is context? Context, and once again, by context I mean the words that are used in the immediate surroundings. So if you see here, the context of the first word A3 the is great. Is you can forget is great. Okay, and similarly is a stop word, so it's great. Now if you talk about A7, so here if you look at the context, here you will find is not so good. This is the context, or but is not so good. This is the context. Now out of these, but, is, not, so, etc. These are like stop words. These do not really consider so much of an information. Apparently, it's really the word good which looks important. Okay. Now we have now just like we had WordNet, we have something called SentiWordNet. What is SentiWordNet? So SentiWordNet I will show you. So SentiWordNet is an online resource of words like this, where every synset of the WordNet is associated with a sentiment polarity, which is like either P or which basically that is a positive score as well as a negative score. So if you look here, every synset is assigned a number which is its positive score and another number which is its negative score. So if you consider the word true, okay, true is a word. In this case, it's like a synset. So true has positive score 1, negative score 0. Means true is considered a very positive word. Next, another second example is illustrious. Now this word illustrious, because we are considering WordNet synsets, along with illustrious I will also consider many synonymous words. Say with along with illustrious, famous, far famed, noted, celebrated, notable, renowned, famed. All of these are basically mean the same thing. So they are being used as a synset. Now this is also has a very high positive score 1 and 0 negative score. That is, it's like saying that it's always used in a positive sense. Now next is real or tangible. Okay, so again these two form a synset. So here the positive polarity is 0.5. So it's like saying that it's a moderately positive word. That is, if I say that is in an arbitrary sentence, if I am using the word real or tangible, it does not necessarily mean that I am saying something good, but more often than not I am probably saying something positive. So that's why 0.5. Now see, but there can be much more complicated situations also, like say real. Okay, so real, literal, actual, genuine. So these are words which can appear in positive sense as well as in negative sense. So accordingly, like these, like both it has a both positive score of 0.25 and a negative score of 0.25. So similarly, there are lots of examples like this. So how are these scores assigned? So again, these scores are assigned with the help of a very large annotated data set, in which that is, whenever every word has appeared, someone has tediously noted, that is as marked, whether that word is being used in a positive sense or not, or negative sense. I mean positive sense, negative sense, or neutral sense. Okay. And based on that, they have calculated the statistics. That is, these words, illustrious, famous, etc. How many times in a large data set, how many times has it been used in a positive context, or in a positive way? How many times this has been used in a negative way? And it has turned out that 100% of the time is positive. But there can be, say, something like, say, semantic, imperative, these kinds of words, which like if you consider that large tagged corpus or annotated corpus, that is, this word semantic, it is never used in either a positive sense or a negative sense. It's always used in a neutral sense. So that is why its positive score is also 0, its negative score is also 0, and so on. So this way, this thing called SentiWordNet has been, this resource called SentiWordNet has been developed by the researchers from Stanford University. And so WordNet, so that is what it does is it takes every scene set from the WordNet and associates a positive score and a negative score to it. Now this SentiWordNet, these scores are going to be important when we are doing the task which we are talking about. So as already mentioned, that is picture quality is great. So here that is in the context, we find this word great. And if you look at the SentiWordNet, we will probably find that its its positive score is 1 and its negative score is 0. That is, it's always used in a positive sense. Okay. So we will assume that regarding this aspect A3, that is the positive polarity is 1 and the negative polarity is 0. That is, it is being something very positive is being said about this aspect A3. But the situation becomes more complicated when we are talking about the second thing, A7. So again, in the like if you look at the context, in the context, these words like but, is, not, so, these are all neutral words or stop words. So these will not have any polarity. The only word which has a polarity is good. And again, we find that this has positive polarity or positive score of 1, negative score of 0. Right? So based on that, I decide that A7, this aspect A7 is associated with the word good, which is positive polarity 1 and negative polarity 0. So I assume that this battery life, we are also saying something positive about battery life, which of course is evidently wrong, right? Why is it wrong? Because of the presence of this word not. Okay, so what is important, so what is necessary here is to look out for negating words. So whenever we are looking, that is this is the target word whose to which we are trying to on which we are trying to associate, with which we are trying to associate a sentiment. But this or these, the target words, they do not by themselves, they do not have any sentiment associated with them. What we are doing is we are identifying some words with a polarity, with a sentiment polarity, and we are trying to induce that same or transfer that same sentiment polarity on our target words. Okay, so that can be done as long as there is no negating words in between them. So in this case, from this positive sentiment word great to our target word, there is just one is. So the sentiment here just automatically transferred to picture quality, the aspect of A3. But in this case, from good to battery life A7, it had to pass through this negating word not. And what effect the negating word had is just to invert the polarity. From 1 0, the polarity became 0 1. Right? So when the sentiment that is was transferred or was induced from good to battery life, it was negated. So what battery life received was the 0 1 polarity, that is positive polarity of 0, negative polarity of 1. So we understood that negative sentiment is being used about battery life. Okay. Now, of course, a sentence may be more complicated. So here we have, that is what we have assumed is that the negating word lies in between the target word and the sentiment word, or the polarized sentiment word, right? But in general, that may not happen. I mean, that is, we write English in so many ways. It may well happen that the sentence is much more complicated, and it may happen that like in the context has mostly positive words, but still the overall sentiment is negative. Like for example, if you see this, the actors are good, the music is brilliant and appealing, yet the movie fails to strike a chord. Okay. So here the aspect words that are being talked about that like acting, music, it's story. These are the aspect words which are related with a movie, right? So in the first step, we with the help of WSD, we were able to identify that this is a target, an aspect word or a target word, actor. And I find that the sentiment associated with this is a positive one, good. About music, I find that it's in its context there is brilliant and appealing, both of which are very positive words. So I think that about music also a positive thing is being said. And then there is this sentence, yet the movie fails to strike a chord. So here, this is actually a rather roundabout thing, right? So that is neither strike nor chord. Neither of these are like sentiment words. On the other hand, fails. This again, like it's a negating word, but it's not necessary. Okay, you can say that it's a in a sense we can say it's a negative word. So that is now due to the presence of lots of positive words in the surroundings, it may happen that our sentiment recognizer may get confused. So that is to avoid these kinds of situations, researchers use various techniques like partitioning the sentence into different groups and so on. So like a bit of it we will discuss in tomorrow's class. Okay. So basically this is the story of sentiment analysis. We'll briefly continue a bit on of this on tomorrow's class. After that, we will also talk about another important topic called word embeddings, and that will be the last lecture